So it can be expressed as dm divided by dA is equal to m divided by A. This is how the fraction of the total mass m and also the surface area can be expressed is like this one. So the m and divided by dA, which this dm and dA represent this should represent the small change of their masses. This is the small change of the masses, and also dA representing the small change of the area for elemental ring, where m represented the mass of the whole sphere, while the A represented the area of the whole sphere. So this fraction give us the equation number 38 for our first topic here. So after this one, my dear student, now let us recall from our figure number 9 for our first topic here. So the area A of the sphere is given by this one. So after obtaining the equation number 38 for our first topic, now we were supposed to recall our figure number 9 for our first topic. Now we should say that the area A of the sphere is given by A is equals to 4 pi r square. Kwa ile area yetu sasa ukilikuwa kwenye ile figure for the whole sphere must be equals to 4 pi r square. And the surface area, where the surface area dA means the area of the ring, must be obtained by taking 2 pi a dy. This is the formula. How can we obtain the surface area for the elemental ring? So after this one, my dear student, what we are supposed to do after this one? So after this one, dA, as I told you that the area for the whole sphere equals to 4 pi r squared. We know that the formula of getting the area of the sphere of the whole sphere is equal to 4 pi r squared. Now for the elemental ring, the area, my dear student, should be given by taking 2 pi a dy. This is how it is obtained by taking area is equal to 4 pi a square. Now we try to differentiate with respect to a. It means dA, it means dA divided by dy now is equal to 2 pi a times the dy. That is what we tried to demonstrate here. And after this one, we know that from our figure that the relationship between dy must be equals to r times the theta, because the ratio of dy divided by the theta must be equals to r. If we make it dy at the subject, we should obtain that dy must be equals to r dq, which represent the theta. This should be the small change of the displacement. Now we were supposed to substitute. If we substitute here from this equation, we should obtain that dA must be equals to 2 pi r a dq, as we observe here. Now after this one, consider dy to be very small, such that if we consider dy, assume that the dy is very, very, very small. If it is very, very small, such that dy is equal to r dq. Kwa kama yule dy ni mdogo sana, basi atakuwa ni sawasawa na r times d theta, as I tried to say here. Instead of writing dy, I have written here r d theta. Now after this one, substituting a and also the a and the a into the equation 4.38. Now we are supposed to substitute our equation. It means that you should take the value of this a and also this dA and substitute into our equation here. If we substitute, we should obtain that dm must be equals to m over 2r square, because we have the common pi and also 2. If we simplify and substitute here, we should obtain that dm must be equals to m divided by 2r square, then we times it by dy. And after there, if we proceed simplifying that, we know that dy is equal to r d theta. If we substitute instead of writing this dy and write r d theta, now here down here we have r power 2, and if we omit this dy and express in terms of r d theta, the r that are found at the top should be cancelled with the r that having the exponent 2, and the remaining one should be dy must be equals to ma, then we divide it by 2 dr, we times it by the theta. So this is how we can find the dm. So after getting this dm, so this should be the equation number 39 on our fourth topic, my dear students. After this one, now let us go and substitute and found the relationship between the cosine theta, the r, and also the a. And we tried to assume on our figure that a must be equals to r cos theta. If a must be equals to r cos theta, now we can from our figure number 9 here, for our first topic, a is equal to r cos theta. If a is equal to cos theta, now we should go and paste instead of writing a, we should substitute. Now if we substitute, we should obtain that if we substitute and reflect for our equation, the I equals to dm r squared divided by 2. Now we should obtain that integration of di from 0 to I must be equal to I. Now is equal to dm. We have already obtained it into our past slide. Now it should remain mr squared divided by 2. Then we integrate it from negative pi over 2 then up to pi over 2. Kwa integration yetu kwamba ile rotation na ile hollow sphere itakuwa inachezea kwenye negative pi over 2 mpaka kwenye positive pi over 2. It means kwenye negative 100, negative 180 mpaka kwenye positive negative 90 mpaka kwenye negative mpaka kwenye positive 90. It means ni pi negative pi over 2 up to the pi over 2. So after this one, my dear student, we were supposed to omit all of that a and also all of that a dy and write in terms of the theta. If after there, now we are supposed to know to recall the special angle for the triangle. As we know that if we take cosine square theta, then we add it by sine square theta is equals to 1. Now we are supposed to make this cosine square theta as the subject. It must be written as 1 minus sine square theta. Then we multiply it by the cosine theta that we observe. Then we multiply it by the this theta. After this one, this should be the equation number 4.40. And after this, now what we are supposed to do, we are supposed to apply the integration. Now integration itakuwaje? Tutalete cha ndani au unaweza uka multiply both side hapa. Ukisha multiply both side means ili kufungua mabano, mwisho wa siku utaanza kuintegrate. Baada ya kuintegrate uta substitute their special angles. So after integrating, my dear student, and simplifying, the moment of inertia for hollow sphere must be equals to 2 divided by 5mr square. Kwa hii ndo itakuwa formula ya kutafuta moment of inertia for the hollow sphere on our fourth topic. So after this one, now suppose the solid sphere and the hollow sphere have the same mass and radius. Now the ratio of the moment of inertia of the sphere is given as it following. Let us imagine that the hollow sphere and also the solid sphere having the same mass and their radius. Now, the ratio of the moment of inertia must be given by taking that the moment of inertia of the solid sphere must be equals to 3 divided by 5. Kwa ukichukua pale ratio kwamba chukua moment of inertia ya whole sphere then divide by the moment of inertia of the solid sphere, utapata kumbe moment of inertia ya solid sphere ni sawasawa na 3/5 ya ile whole sphere. And always we know that the solid sphere the moment of inertia for a solid sphere is less than the moment of inertia for the whole sphere. So by saying that this is the end of our session here, my dear student, now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.